Hello everybody, welcome back to Online Algebra, whatever week this is at this point. So last week we said we were going to jump into chapter 11 for a little bit and then we're going to jump straight into chapter 12. We're going to get started with section 12.6, Permutations and Combinations. Let's get started with that start thinking. Now if you had 3 shirts, 2 sets of pants, and 2 pairs of shoes, what's the total number of outfits you can make? So let's think about this. Let's say you have a red shirt, a blue shirt, and a yellow shirt. Let's say you have a pair of jeans and a pair of khakis, as well as a pair of sneakers and a pair of high tops. So we have 3 shirts, 2 pants, and 2 shoes. We're trying to determine the number of outfits we can make. Well, there's a couple of different ways to deal with this, but we're going to look at something called a tree. What that is we're going to start by saying, okay, what if we wear a red shirt? Well, then what are our options for pants? Well, we can wear either jeans or we could wear khakis. And depending on what we wear, we could choose to wear either sneakers or we could wear high tops. And the same is true for khakis. We could wear sneakers or high tops. Okay, what about if we wore a blue shirt? Well, with a blue shirt, we could wear jeans or we could wear khakis. And again, we could wear sneakers or high tops with either the jeans or the khakis. And the same is true for the yellow shirt. For the yellow shirt, we could wear jeans or khakis, and we could wear sneakers or high tops. And so what happens is each of these makes up a unique outfit we could wear. We could wear a red shirt, jeans, and sneakers. We could wear a red shirt, jeans, and high tops. We could wear a blue shirt, khakis, and high tops. So how many outfits do we have? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We can make 12 different outfits from these 3 different options. And this leads us to our first point. The first really key point for this lesson is something we call the multiplication counting principle. What the multiplication counting principle says is that if we have m choices for thing 1, and we have n choices for thing 2, then if we're trying to look at both things, if we're trying to combine them, then we're going to have n times n choices. So then there are m times n choices for both. Right. How does this work? Well, let's say we have 3 shirts and 2 jackets. Let's make that 4 jackets. 3 shirts and 4 jackets. And what this means is if we're looking for different sets of shirts and jackets, we will have 3 times 4 shirt and jacket combos. We will have 12 shirt and jacket combos. So instead of going through and making that tree, we can just multiply them together. Let's run through an example like that. Let's say you are creating a pizza. And for the pizza, you have 4 different types of sauces that you can have. And there's a total of 12 different toppings. So how many one-topping pizzas can you make? All you need to do to determine the number of one-topping pizzas is you multiply the number of sauces times the number of toppings. Right? We have 4 different sauces we can combine and 12 different toppings. So our total number of one-topping pizzas will be 4 times 12, or we will have 48 different one-topping pizzas. Right. Now let's talk about something that will be new to you. You might have seen a button on your calculator, or you might have not. That looks like this. An exclamation point. And this is not mathematicians' ways of saying, hey, we're super excited about n. This is instead something we call a factorial. What a factorial means is that we take every number and we multiply it from n, and we multiply by everything smaller than it. So n factorial is just n times every number smaller than it. So for example, if we have something like 5, and that's not just a really excited 5, that we read that as 5 factorial, that's the same thing as 5 times every number smaller than it. So 5 times 4 times 3 times 2 times 1. Or this would be 20 times 6, 120. In the same realm, 7 factorial, not exclamation point, would be 7 times 6 times 5 times 4 times 3 times 2 times 1. Now, where would these come up? We'll cover that a little bit later, but factorials are actually kind of important when it comes to dealing with choices. Right? So we were dealing with choices here. We were trying to determine the different number of pizzas, but we'll be dealing with slightly different choices. Now let's say you're trying to look at something and you're trying to determine the choices. Let's say specifically you're looking at something like trying to choose who's going to be first, second, and third from a group of people. We call something like this a permutation. And what a permutation is it's choosing a number of objects where the order matters. Right. So what do I mean order matters? Well, some example of this, like we said, would be, let's say you're choosing the first, second, and third place person from 5 different people. So there's 5 people running a race, and you're trying to figure out who could take the first, second, and third place. Maybe the boss said, we're going to just make a first place trophy for everybody, a second place trophy for everybody, and a third place. And you're trying to figure out how inefficient that is. Right. What else would it be where order matters? Well, let's say you're trying to organize something. Let's say you're organizing all of your trophies. If we're organizing trophies, then having the chess trophy first, the swim trophy second, and the math trophy third would be different than if we put the swim trophy first, the chess trophy second, and the math trophy third, right? Either of these would declare a different amount of importance, and both of these are wrong because math is clearly the most important trophy there. Now, our formula for permutations. We have a specific formula, and that formula is if you have n choices, and you're choosing R objects, we write this as we have n objects we're choosing, we're picking or we're permuting R of those, and the formula for that is it reads n factorial over n minus r factorial. Now this is where factorials come in, but honestly this is a little ugly, so I'm going to show you a shortcut. But let's go back and look at some of these. We're choosing 3 people from 5 people. So 5 people is going to be our total number, and we're choosing 3 people. So what would this be? We're choosing 3 people, so that makes us R. Well, n is going to be 5, and we're picking 3 of them. All we have to do instead of using this ugly formula down here, so we have to say, all right, well, we're choosing 3 of these, so we're going to make 3 spaces, and we're going to count down from 5. So starting here, we're going to start with 5, and then we're going to choose 1 less each time. We have 5 choices for the first place position. We have 4 choices, right? We've chosen 1 person for the first place, so we only have 4 choices left. This is all a permutation is. When we're looking at it, you make this number of spaces, and you multiply them by that number multiplying down. That's the easy way to think of a permutation. All right, so let's look at an example of this. An example of this would be you have your top 10 movies. So from your top 10 movies, whatever those top 10 movies are, you're going to be ranking the top 5, the obvious, clear top 5. And so does order matter on this? Well, yes, if you're choosing Citizen Kane first, then you're choosing Lord of the Rings, and then a Star Wars movie, then Harry Potter, and whatever. That's different than if you put Harry Potter first, then Lord of the Rings, then Citizen Kane, and so on. So this one matters, right? This first place matters. That's clearly the best movie. Then the second place matters. So order does matter. This makes it a permutation. Now, how many movies are we choosing from? We're choosing from 10. That'll be n. And we're ranking how many? We're picking 5 of them. So this will be 10 pick 5, or 10 permute 5. What does that equal to? Well, we make 5 different spots, and we're going to multiply from 10 down until we fill out the spots. So 10 times 9 times 8 times 7 times 6. We take this number and we multiply down from it. This will tell us the total number of different options we have for ranking our top 10 movies from first to fifth, whatever that number comes out to be, which let's put it into our calculators. Turns out there are 30,240 different ways to rank your top 10 films, choosing the best 5. All right, what about if order didn't matter? What about if you were just saying, no, I just need to choose the 5 that are the best movies, or we just need to choose the top 3 people and they will all get equal praise? That's something we call a combination. And what is a combination? A combination is picking when order doesn't matter, or arranging when order doesn't matter. So what would be some examples of this? Well, this would be you're choosing the top 5 people who are all going to get a prize from 20 raffle tickets. How do we know order doesn't matter here? Well, if we chose Alice, then Bob, then Charlie, then Dave, and so on, does it matter whether Alice comes first or whether Dave and then Charlie come first? It doesn't. All of them are getting the same thing. So this is going to be a combination. What would be another one of these? Well, we're all in quarantine here, so if you're choosing 2 games out of the 5 to play, 5 that you have to play, does it matter whether Chutes and Ladders comes first and then Candyland comes? Or does it matter whether you play Candyland, Chutes and Ladders next? Doesn't really matter, so this is going to be a combination. Now our formula for a combination, and unfortunately this one you're going to have to keep a little bit better eye on. The formula is if you're choosing from n different things, and you're choosing r of them, then the way we write this is as n choose r, and what that looks like is it's going to be the permutation of r divided by r permutation r. Now that can be a little confusing, so let's take a look at an example. Let's say we had those 5 winners from the raffle tickets, from 20 raffle tickets. All right, so we're choosing from 20 people, and we're picking 5 winners. So this is going to be 20 choose 5 of them. What is that going to be? That's the same thing as 20 permute or pick 5 divided by 5 pick 5. Right. And what did we say these are equal to? Well, this is, we're going to make 5 different spaces, and we're going to count down from 20, multiply them together. So 20 times 19 times 18 times 17 times 16 divided by, this is, we're going to pick 5 spaces, and we're going to count down from 5 together. So 5 times 4 times 3 times 2 times 1. And remember, when you're putting them in your calculator, do the top, then do the bottom and divide them. So 20 times 19 times 18 times 17 times 16 is going to be, 1,860,480. So this is going to be equal to 1,860,480 divided by 5 times 4 times 3 times 2 times 1. Or 120. And so this will tell us the total number of different groups of 5 winners who will come from this 20 raffle tickets. So we find out that there will be a total of 15,504 different groups of 5 people who can win this raffle. So when we're doing combinations, that's where order doesn't matter. We're going to use this formula where you choose the total number of people, you mark out the total number you're choosing spots, and then you divide it by all of the different ways that we can write that. The really important part here is we have to be able to determine whether order matters. So let's do some practice with that. Right, so I'm going to give you a couple of examples, and then we're going to work through how do we determine whether order matters. So first of all, let's say we're picking 4 toppings. Does order matter? Well, the way we check this is we make a list of toppings and then see whether it's going to change. So if we choose pepperoni, then we choose sausage, then we choose artichoke hearts, and then we choose banana peppers, does that change if we choose banana peppers first, then we choose artichokes, then pepperoni, then sausage? No, it doesn't really matter which order these toppings go on. So order doesn't matter. All right, what about if we're arranging people for a photo? Now, does it matter if Grandma comes first, then your aunt comes first, then Charlie goes next, then Billy? Or does it change when Billy goes next, then Grandma's next to him, and Charlie's next to the Grandma, and your aunt's next to Charlie? Well, yeah, we're going to get 2 different photos here, right? It matters whether Grandma's on the end or whether she's stuck in the middle. So this is going to be one where order does matter. And finally, let's look at one more example. Let's say you're ranking your best 3 books of all time. So does it change if you put Cat in the Hat first, then To Kill a Mockingbird, and then the Butter Battle book? Or does it matter if To Kill a Mockingbird comes first, then you put the Battle book, then Cat in the Hat. Well, it does, because this first order says Cat in the Hat is the best book ever, 100% no doubts. And this one says To Kill a Mockingbird is the best book, 100% no doubt. So these do change what we're saying, meaning that order does matter. Right, that's all we have, so I'm going to give you some practice problems. Make sure you understand this, then you can get on to the homework. First of all, I want you to just calculate a couple of things. So let's have you calculate what 6 factorial is. Remember, that's not an exclamation point. Let's have you figure out what 9p4 is going to be and what 7c3 is going to be. Then I want you to tell me what our total number of outfits can be. So for problem 2, what the number of outfits can be when you have 4 pairs of pants and 8 different shirts you can wear. Then I want you to look and determine how many different 4-topping pizzas we can have. So this is problem 3. Different 4-topping pizzas. When you have 15 toppings to choose from. And then finally, I want you to tell me whether order matters or not on these. So, does order matter when we're looking at rearranging a bookshelf? And does it matter when we're choosing 3 desserts? All right, so go ahead and do these practice problems. Then we'll meet back up, go over them, make sure you understand them, and then you can get started on the homework. But make sure you're actually doing these. All right, pause the video, make sure you're doing these. Welcome back. Let's get started with problem 1. What is 6 factorial? Well, that's the same thing as 6 times 5 times 4 times 3 times 2 times 1. Put that into your calculator to figure out what that is. You find out that 6 factorial is equal to 720. All right, 9p4. We said this means you pick out 4 different spots, and we go down from 9. So 9 times 8 times 7 times 6. What does that equal? Throw that into your calculator to find out. You get 3,024. Right, 7, choose 3. This one's a little trickier. We said this is the same thing as 7p3 divided by 3p3. So this is going to be 7 times 6 times 5 divided by 3 times 2 times 1. Or this will be equal to 35. Now for problem 2, it says we're looking for the number of outfits when we have 4 pairs of pants and 8 shirts. This is just that multiplication principle where we say we have 4 different options for the first one and we have 8 different options for the second one. So our total number of options is going to be 32 different outfits. For this third one, we're choosing 4 different toppings of pizzas with 5 toppings to choose from, or 15. Doesn't matter whether pepperoni goes first and sausage goes next, or whether sausage goes first and pepperoni goes next. It does not matter. So order doesn't matter. Which one does that apply to? That applies to combinations. So we're choosing from 15 toppings and we're picking 4 of them, meaning that this becomes 15 picking 4 dividing by 4, and we're picking 4. All right, let's do the math for that. 15 pick 4, we make out 15 places and we multiply down. So 15 times 14 times 13 times 12 divided by 4 pick 4, we work our way down from 4 spaces. So 4 times 3 times 2 times 1. Put that into your calculator to figure out what that's going to become. 4 times 3 times 2 times 1. And you find that there are a total of 1,365 pizzas you can create. All right, now let's look at, does order matter? Does order matter when you're rearranging the bookshelf? Once again, does it matter whether we have Lord of the Flies first, and then Cat in the Hat, and then Harry Potter, or does it change when Harry Potter goes first, then Cat in the Hat, then Lord of the Flies? This changes the order of the bookshelves, so order matters. All right, what about for choosing 3 desserts? Well, if you choose ice cream first, then pudding, then a sundae, does that change then whether you eat the sundae first, then the pudding, then the ice cream? Doesn't. You're going to feel horrible after either of them, but the order doesn't matter. Right, that's all we have for this video. So go ahead and get started on the homework. Apologies for the long lesson here.